Okay, good morning, class. So I just want to continue uh, our discussion of velocity. So last time we spoke about having um, three kind of scenarios for velocity. One where the velocity is not particularly steady, one where it's rock solid steady, and one where it is steadily increasing or decreasing. Okay, so those are our basic scenarios. I just wanted to continue talking about that for a minute. So let's begin by repeating what we spoke about when we last left off, which is this scenario over here, the steadily changing velocity. All right. So let's just, I know we did it at the end last time, but let's just do it again. And let's just use this example, a car traveling on a straight road at 15 meters per second. So straight road, we're just talking about straight line motion. So it's initially traveling at 15 meters per second. So that would be our initial velocity. We call that VI or VO, for V initial or V original. And it accelerates, which just means it changes speed, uniformly accelerates though. So it changes speed in this linear fashion. It steadily goes up or steadily goes down to a speed of 21 meters per second in 12 seconds. Okay, so it steadily speeds up to 21 meters per second. And this is at over a 12-second time period. This is time on this axis. And since this is the ending velocity at the end of this 12 seconds, we call this VF or V final. Okay? And it's asking us, what is the total distance traveled by the car in this 12 seconds? Well, we know distance is average velocity times time. So the question is, in this scenario, can we figure out average velocity? And when you're steadily increasing, average velocity is the midpoint between your starting velocity and ending velocity. So we started at 15 and ended at 21. Okay? And one way to find the average is basically to add the beginning number and the ending number and divide by 2. So one way is to say average velocity is my initial velocity plus my final velocity divided by 2. Just average them. Okay? Now my initial velocity is 15. My final velocity is 21 meters per second. And so I'm just going to add them up and divide by 2, which gives me 36 divided by 2, which is 18 meters per second. Now this also turns out basically to be the midpoint. So if you can kind of say what's right smack in the middle of 15 and 21, well, you'd say if I add 3 to 15, I get to 18. And if I add 3 again, I get to 21. So right smack in the middle of 18 and 21 is, right smack in the middle of 15 and 21 is 18. So you can kind of determine this average velocity by adding up the beginning and ending velocity and dividing by 2, or you can just kind of say what's right smack in the middle of these two numbers. All right, but we have average velocity now, and then we know distance equals average velocity times time. So it's 18 meters per second times 12 seconds, and that is going to equal 216 meters, and we have our answer. Oops, sorry about that. Okay. All right, anyway, 216. My pen doesn't seem to want to go all the way down to the bottom of the screen there. But it's this one, 216. Okay, now let's just summarize things and discuss notation a little bit, just so we're comfortable with it. Here's our reference table, and we see a few different symbols associated with velocity. We see this V with a bar over it, which hopefully we recognize that's average velocity. And I know we haven't discussed these formulas, but you're going to see VF and VI, which we've already mentioned. So VI is initial velocity, That means the velocity at the beginning. And VF is final velocity. Okay, so just recognize that these there are different symbols here, but they don't really, you shouldn't be intimidated by it. V bar just means average velocity. VF is the final velocity. VI is the initial velocity. Now this VI and VF really only, and you can see, again, we see VI in this formula, and you see VF in this formula down here. But it just means when VI and VF really apply to situations where the velocity is constant the whole time, or constantly increasing or constantly decreasing. Okay, so here it would be appropriate to talk about, well, sure, I can find the initial velocity. If I can consider an initial velocity and a final velocity here. They're the same thing. It's a constant velocity. But let's say my velocity here was 10 meters per second. I have a constant velocity of 10 meters per second. Well, I could say at the beginning, my initial velocity was 10 meters a second. At the end, my final velocity was 10 meters per second. And I could use this formula for average velocity. I could say 10 meters per second at the beginning plus 10 meters per second at the end is 20 divided by 2 is 10. So my average velocity would be 10. And here, using VI and VF also makes sense. If I said I started off at 10 meters per second of velocity, my initial velocity was 10 meters a second, my final velocity was 20 meters per second, what's my average velocity? My average velocity would be my final velocity, which is 20, plus my initial velocity, which is 10, divided by 2. 30 divided by 2 is 15 meters per second would be my average velocity. So when we're talking about VI and VF, velocity initial and velocity final, it really applies to these two situations where we have a constant velocity and in particular a steadily changing velocity. So you can use this method for calculating average velocity in these two situations where you have constant velocity or steadily increasing or steadily decreasing velocity. It wouldn't make particular sense to talk about, well, my initial velocity in this situation was, I don't know, let's just say 10 or something over here, 10 meters per second. And my final velocity over here was, I don't know, 11 meters per second. In this situation, you can't use this formula to calculate average velocity because your velocity is not steady. It was changing all over the place. So this formula for average velocity being the distance that was traveled divided by time, this applies to all situations. So yes, we use it for situations where the velocity is not steady. We use it for situations where the velocity is steady, and we use it for situations where the velocity is steadily increasing or steadily decreasing. So this formula we can use all the time. This way of calculating average velocity only applies to constant velocity here and steadily changing velocity here. This formula would not be appropriate to use if the velocity was changing in a non-linear fashion as the object was moving. Okay, so just want to kind of highlight that. This formula, average velocity equals distance over time or displacement over time, that's good for any situation. That's good for velocity changing all over the place. It's good for constant velocity, and it's good for steadily changing velocity, steadily increasing or steadily decreasing. If I'm going to say what's my average velocity, it's my ending velocity plus my initial velocity divided by 2. That only applies if I have a constant velocity situation or a steadily changing velocity. Okay, and then I also just wanted to highlight some of the notation. The little bar over the top means average velocity. The little I means initial. The little f means final. All right. Okay, let's just do some problems and and hopefully you'll see how easy it is. All right, here we go. So this one's from Khan Academy. As shown in the figure below, Lewis rushes 40 meters towards his truck. So Lewis goes for 40 meters. He notices he forgot his shoes and he returns back to his house. So, oops, 40 meters back. Whoop. Okay, and his total time is 60 seconds. And what is Lewis's average velocity? Okay, well, we know average velocity equals displacement over time. And in this case, he started at his house, he came over here, he came back, he ended at his house. So his displacement is 0, time is 60 seconds, and so his velocity is 0 meters per second. All right, and then the second question, you can kind of see it here. What is Lewis's average speed over the 60-second period? Well, average speed, maybe I will use an S just to make it different. Average speed equals distance over time. Okay, well, the time we know is 60 seconds, and his distance was, if he moved 40 meters and then he moved another 40 meters, so his distance would be 80 meters. Okay, and 80 divided by 60 is the same as 8 over 6. If we divide top and bottom by 10, you'd get 8 over 6. Divide top and bottom by 2, you'd get 4 over 3. And so we've got 1 1/3 meters per second, or if we wanted to enter it as a decimal, 1.333 meters per second. Okay, so this problem was pretty simple, just using our simple relationship: average velocity equals distance over average speed equals distance over time, average velocity equals displacement over time. All right, let's go to the next problem. This one's out of positive physics. Okay, here a bicyclist travels with a constant speed. Okay, so now we're talking about our constant speed, constant velocity situation. At constant speed of 7 meters per second, we're at 7 meters per second for 6.4 seconds. Okay, so we're just same speed for 6.4 seconds. And it wants us to determine the average velocity. This is a distance. This is the notation for distance in positive physics. Delta x means change in your distance, and delta t means time. Okay. Well, a couple of them they gave us, as with whenever we're using an equation like distance equals speed times time, or displacement equals velocity times time, they're going to give us two things and ask us to solve for the third. Well, they gave us two things: 7 meters per second. So we just plug in average velocity is 7, and we know average velocity is 7 because it's constant velocity, right? Our initial velocity was 7, our final velocity was 7. 7 plus 7 divided by 2 is 7. So we know our average velocity is 7, and what are the units? 7 meters per second. So you have to enter two things. You have to enter what is the average velocity and what are the units of that average velocity. Next thing you want to know is, let's take the next thing that they gave us, time. 6.4 seconds. So time, we simply enter 6.4. What are the units of time? Seconds. Okay? And then we have to figure out distance. But we know distance equals speed times time, or displacement equals velocity times time. So we plug in our information. Here's our little bicyclist over here. So our velocity is 7, and our time is 6.4 seconds. Seconds are going to cancel with seconds. We multiply those two numbers, and we're going to get 44.8. What are the units of distance and displacement? Meters. Okay, so then we plug in our change in position, or our distance and displacement is 44.8 meters. Okay, they're not asking us for a direction. The direction would be sort of in the positive direction. So we can answer the problem. So what they're looking for here is plug in your knowns. Velocity, 7 meters per second. Time, 6.4 seconds. And then calculate distance. Distance equals speed times time. Distance equals velocity times time. Displacement equals velocity times time. So you simply multiply speed times time and you get your distance. Okay? All right, let's do another one. The car travels at a constant speed. Okay, again, a constant speed problem. So you should be thinking, which scenario am I dealing with here? Am I dealing with a velocity that we don't know if it's constant or not, a velocity that's constant, or a velocity that is changing in a steady fashion? So here we're in constant velocity. So they give us two things, 9 seconds and the velocity, 26 meters per second. So let's plug in those two things to begin with. So for time, we're going to plug in 9. And what are the units of time? We're going to use the pull down and select seconds. Velocity, they gave us 26. What are the units of velocity? Right there, meters per second. 26 meters per second. That means I travel 26 meter sticks every single second. And so if I travel 26 meters every second and I do it for 9 seconds, how far did I go? Well, all right. The distance equals speed, average velocity, or average speed times time. Okay, so we would say our average speed, constant speed, average speed is 26 meters per second. And if they tell us it's constant, we know that that is also the average times 9 seconds. And then we multiply that, okay? So 9 quarters. I'm going to break this into 26. I'm going to break into 25 plus 1 because I like money math. So 9 quarters would be $2.25. And 9 times 1 would be 9 cents. So this would give me 2. Oops, what the heck just happened? There we go. This would give me 234. Okay, so 234. Hopefully I did that right. So we plug in 234. What's the units for distance? Meters. And we're done. Okay? So very simple. But what I want you to get in the habit of is what situation am I dealing with? Am I dealing with a constant velocity, steadily changing velocity, or a velocity that is inconsistent? All right, let's do another one. A bicyclist starts from rest. A bicyclist steadily speeds up from rest to 11 meters per second. Okay, so which situation do we have? Well, let's first see what we have here. From rest. From rest means from stopped. And if you are stopped, your velocity is, or your speed is 0. So we'd say they just told us that at the beginning our speed was 0. And then you are speeding up to some other speed. So they basically told us the initial speed and they're telling us the final speed. Okay? And they're telling us that we didn't get from here to here in kind of an inconsistent way. We got here in a steady way. We steadily speed up, right? So they're telling us we have this situation. They're telling us our initial speed is 0 meters per second, and we steadily sped up very linearly to 11 meters per second. Okay, so when you get those two bits of information, you should say, I know how to find the average. I just add those two numbers and divide by 2. 0 plus 11 divided by 2 is 5.5. So I know our average velocity now, which is great. Okay, but now let's start plugging stuff in. So VO, in this means V original, or that means, or what we should think of as V initial. Okay, so our starting velocity. So we would plug in our starting velocity is 0. Okay, and what is our final velocity? Well, our final velocity, VF, F stands for final, is 11 meters per second. And therefore, what is our average velocity? Well, our average velocity is, when we're steadily changing velocity, we know our average velocity is going to be right in the middle. So our average velocity is 5.5 5 meters per second. Okay? And just in terms of the pictures, you can see here he's got these little like marks next to him, and you can see his feet are off the ground in this picture. So that's just an indication that he's moving. And over here, you don't see those little lines behind him, and you can see his foot's kind of on the ground. So that's an indication that he's not moving. So just so you're aware of that in the pictures. Okay, this one is from a Regents exam. So let's see what we got here. It says the speed of an object undergoes constant acceleration. Acceleration means a change in speed. So constant acceleration. And the word constant means uniformly changing. Okay, so constant acceleration means this situation. Your speed is changing in a uniform, constant fashion. Okay, and it increases from 8 meters per second. So it starts at 8 meters per second. And it increases to 16 meters per second. Okay, that's over here. 16 meters per second. Okay, so it just told us we steadily increase our speed from 8 meters per second to 16 meters per second, and that takes place over a 10-second time period. Okay, this axis is time. Okay, how far does the object travel during this 10 seconds? So we want to know distance. Well, we know distance equals average velocity times time. This relationship holds for all situations. So we know distance equals average velocity times time. We just have to figure out our average velocity. So our average velocity is our starting velocity plus our ending velocity. So 8 plus 16 would be 24, divided by 2 would be 12. Our average velocity, 12 is right in the middle of 8 and 16. 8 plus 4 is 12. 12 plus 4 is 16. So our average velocity, 8 plus 16 divided by 2 equals 12 meters per second. Okay? And then we can simply answer our question. Our distance is our average speed times time, or our displacement is our average velocity times time. Okay, well, our average is 12 meters per second in the positive direction, times time was 10 seconds. So this should be 120 meters. All right, so now the trick is, well, which one of these looks like 120 meters? Well, 1.2 times 10 twice would give us 120 meters. So this is just 120 meters written in scientific notation. So that would be our answer. All right, and I think, yeah, that's it. All right, so just wanted to give you those problems and kind of review a few problems. So to me, the easiest way to solve these problems is to just make sure is to understand there's lots of different notations. You got these VIs, you have VFs, you have a V with a bar over the top, you got all these things going on, but it's not as complicated as it sounds. There's really only 3 situations you're going to be dealing with where the velocity changes in an irregular way, a situation where the velocity is constant the entire time, or a situation where the velocity is changing but in a very uniform way. It's constantly increasing or uniformly decreasing. And we have 2 kind of simple relationships. Average velocity is distance over time. And we can also figure out the average velocity in these 2 situations just by looking at the beginning velocity and the ending velocity, adding them up and dividing by 2. So 8 plus 16 divided by 2 is 12. We can figure out our average velocity if they give us the starting and ending velocity. And same thing here. If we said constant velocity of, I don't know, let's say 14. Well, if it's constant, it's 14 at the beginning, it's 14 at the end. And what's 14 plus 14 divided by 2? 14. So we know our average velocity is going to be equal to whatever our constant velocity is. Okay, so hopefully that helps. So you're going to get lots of different scenarios, but just be thinking, is this a constant velocity situation? Is this a steadily changing velocity situation? Or is this a situation where they're not really describing how the velocity is changing, or it's not clear how the velocity is changing. And they all are going to use this formula, and you can determine the average velocity in these two circumstances as described using just beginning velocity plus final velocity divided by 2. Okay, so hopefully that'll help you solve some of the problems, and we will talk later. Thank you.